Hello, and welcome to Apache TinkerPop's home here on Twitch. Today we have another TinkerPop Wide stream, and that's where we look at the wider TinkerPop community, viewing tools, libraries, graph systems built on the TinkerPop framework, or even applications built on those foundations. And today we have Arthur again, creator of G.V, to catch us up on the latest developments in their TinkerPop tooling. So, and what future plans exist out there for this coming year in 2025. So, thank you for joining us today, Arthur.
Thank you. Glad to be here again. Hi, everyone.
Quick reminder, we're definitely taking questions from folks, either here in Twitch or in Discord in the events channel. So feel free to ask questions as we go, and look forward to seeing what you have, Arthur. Go ahead.
Cool. Thank you very much. Okay, so today I'd like to kind of talk through some of the recent updates that have been happening on G.V as well as future plans. So I've titled this presentation From Gremlin IDE to Graph Database Client, which is sort of a nod to the overall evolution that the software is taking. For those of you that have maybe used it in the past, you'll know that we've been focused specifically on the Apache TinkerPop ecosystem for quite a few years now. And now that we're moving forward and actually working on this more, we're starting to branch out to other graph technologies. So just before I kind of go over all this, I'm just going to very, very briefly reintroduce myself. So my name's Arthur Bigeard. I am the creator of G.V that I've been working on for a few years now. G.V itself is available both as a software executable and a web deployable interface, and it essentially allows mostly developers, but also data analysts to just do day-to-day tasks on their graph database, whether it's on Apache TinkerPop system or on some other systems that we'll be covering in a minute. So our goal really is to offer a unified kind of tooling that allows graph database adopters or graph database experts both to just have a consistent user experience when they're working on their graph databases, with a goal to just overall increase their productivity. So you can think about things like, well, how do I write my queries faster? How do I visualize my results? How do I present this information perhaps to external stakeholders, people that are maybe not going to be as technical? This is the type of problems that G.V exists to solve. And so overall, what we say now is that one of the main reasons you would want to use G.V is to simply experience graph databases just the same way you would relational databases that have been around for decades now and have had this years and years of developing their own ecosystem and tools that everyone that comes to these databases knows to expect. And we're trying to essentially deliver on that expectation for graph databases. So as I've alluded, we're kind of evolving. G.V, given the name, was very much a Gremlin product. The goal was to help those Apache TinkerPop users get more done, to go from using something like the Gremlin console to something a lot more visual. And so what we've done is we're actually starting to support now new querying languages. We're focused mostly on the labeled property graph space at the moment. So our main recent updates is the addition of support to the Cypher query language, first with Amazon Neptune, but then also with Neo4j and memgraph. But we're also trying to move away from just being a desktop solution, being something that you install on your computer, you're going to be using on your own. You might have teammates that also use G.V, but ultimately each is going to have their own installation with their own configuration, etc. And so we've got a new web application version available on AWS Marketplace, which I'll be demoing later, that allows you to use G.V no longer just as an individual, but rather as a team. So what's been happening recently is that we've expanded to those new graph database technologies and language. So we've added Cypher support for Amazon Neptune, first of all, and that was in November last year. So as you probably know, Amazon Neptune supports Gremlin, Cypher, and Sparkle. We are now able to support Gremlin and Cypher. It actually is usually is the first one that we start supporting Amazon Neptune, because it supports all of the main structures and languages of graph databases. It becomes de facto the easiest one to integrate with first. Afterwards, and that was actually just a month ago now, we've added support for Neo4j ORDB, as well as the local version, memgraph, and Neptune Analytics. Neptune Analytics, if you're not familiar with, is the sort of OLAP version. Apologies if I'm butchering the description there, Stephen, of Neptune that allows you to perform large-scale analytics on graph data within AWS. And we've also added the first version of GQL support for Google Cloud Spanner Graph, which was just recently announced as generally available. So what that means now is you can actually query your graph data in not just Gremlin, but also Cypher and GQL. There's a bit of nuance around the GQL statement because the way Google has implemented support in Spanner Graph means that it's not just GQL, it's sort of SQL as well. So there's a lot of things you can do there. But the point is that we're basically supporting more and more technologies as we go. We've also released the first web application version of G.V on AWS Marketplace back in November last year. This is something that we currently only have available on AWS Marketplace. Generally speaking, it's G.V as a Docker container. Simple as that. We haven't quite worked out how exactly we're going to offer it outside of cloud marketplaces, but we're trying to work towards this. So if you happen to be interested in using this web version that we'll be demoing in a minute outside of AWS, give us a little heads up, and we'll see if we can get you set up to try it out. The other thing is, so this is possibly for people that have been aware of G.V existing for a while, or that have maybe participated in one of the streams that I did before on TinkerPop Wide. G.V was, up until June last year, maintained by myself alone whilst working a full-time job somewhere else. And so what that meant really is that you really just had half of me working on the software. Ultimately, the impact here being that we're not going to get as much stuff done. It's more time consuming. I've got a divided attention. We are now actually a team. So it's myself working full-time, as well as a junior developer that has joined me in June as well, who's both training and skilling up on graph databases, as well as actually contributing features to the product. So new things that you'll be seeing on the software might not actually have been done or coded entirely by me. And it's a really good setup because it just means, effectively we've quadrupled our work capacity, quote unquote, and that just allows us to get a lot more done. So I'm just going to take you over to this AWS Marketplace version real quick. As I've mentioned, it's a web application version. It's a really simple one. Essentially, G.V has always kind of been developed as a web application, but we've wrapped it up to be a desktop executable. All we've done is taken the web application side of G.V and turned it into a Docker container that is then deployed alongside a couple other components, a database to store the configurations, as well as a reverse proxy to handle the usual web stuff like TLS termination, load balancing, etc. All of that available directly on AWS Marketplace. So this version is particularly intended for Amazon Neptune users, but it is compatible with all of the graph databases we support. The reason I'm saying it's particularly intended for Amazon Neptune users is that since it is deployed on AWS Marketplace, it also benefits from all of the integrations with the AWS ecosystem as well, particularly the ability to configure, for instance, IAM roles. So G.V itself is basically deployed on a simple EC2 instance. Typically, you would deploy that in the same VPC as your Neptune cluster. And one of the things you can do is configure your EC2 instance to have an instance profile that will provide it credentials to connect securely to your Neptune instance. That basically just allows you to, instead of having to provide AWS credentials on the G.V UI to connect to Neptune, just do it directly through credentials delivered from the AWS cloud ecosystem to your EC2 instance. So I'm just going to go ahead and give a little demo because right now I've been doing a lot of talking about what's been done and what there is, but perhaps some of you have not heard or seen G.V before, so that will kind of be your first look. I'll be using the, yep.
Sorry, we did have a question. I'll
yeah, of course,
here for you. And thanks, Josh, for joining. Any support planned for RDF, especially RDFS and Al?
I actually have a slide about RDF. Right now, we've been focusing on the label property graph database space because it's the one that we've been used to, having worked with TinkerPop. However, we're very keenly aware of the existence of RDF as an entirely other half of the graph database space that we're completely not addressing. Yeah, long story short, we do have plans to support RDF. I've actually got a more detailed plan of how that's going to happen in a few slides, so I'll go over it there. But we started consulting with some people in the industry to kind of give us a good idea of what that might look like and how it might be done. So what I'll do is I'll continue with the demo, and that's going to be 3 slides after that. I'll be sort of laying out the full plan to hopefully achieve RDF support in GDLV. So long story short, absolutely. RDF is a space that we want to get invested in. It will happen in stages.
Cool. Thanks. And thanks for the question.
All right. So this right here is G.V. So I've actually currently got 2 databases connected. I have got an Amazon Neptune cluster, and I've got an ORDB, Neo4j ORDB connection as well. What I'm going to do is I'm going to kind of walk you through the initial experience. So what I've done is I've created a little Neptune graph, so Neptune Analytics. We're just going to briefly go through how connecting to it works, and then what you can then do once it's connected. So I've loaded it with some sample data, so none of the stuff you're going to see is real data, of course. It's just synthetic stuff. I have my Neptune Analytics graph right here. It's configured with a public endpoint, which is what I'm going to be using to connect to it from G.V. So all I need is the public endpoint. We're going to create a new database connection. So as you can see, the list is getting quite long. We've got quite a few in there, and that's going to be a growing list. In this case, it's going to be Amazon Neptune Analytics. Now, this EC2 instance that G.V is running on is pre-configured with an IAM instance role that grants it access to both Amazon Neptune clusters and Neptune graphs. So all I need to do to get connected is to just specify the region that my Neptune Analytics instance is running in, and then test the connection, and we are good to go. So once you're connected to your graph database, and this general experience applies to all the graph databases we support. You know, sometimes there are different steps. Different databases have different requirements in terms of authentication or configuration, but the overall experience of give us the initial details, and then we'll walk you through how to get fully connected to the database remain the same. Typically just takes a couple of minutes. Once you're connected, there's a few things that happen. First of all, you'll be able to just query your data. So because we're using Neptune Analytics, we can only currently use Cypher, as we don't support Sparkle or RDF just yet. You can just go ahead, run your query, and you'll start being able to visualize your results. Now, depending on the nature of the query, you're going to see different types of visualizations. For instance, this query here returns a Cypher path, and apologies, I know we're on the Apache TinkerPop audience, so I'm going to swiftly move away from Cypher. That returns a bunch of graph elements that can be turned into a visualization. The visualization itself, you can see right now, is a little bit bare bones. It's just going to tell us, you know, what sort of elements we've got. So in this case, it's tweets and users. It can be very easily configured to give you, relevant information. So for instance, for our tweets and users, we're going to display the text of the tweet and the actual name of the user, and save that. And then suddenly, boom, you can sort of see your graph data being displayed with relevant information. We've got, other useful displays. For instance, when you run a query, it's going to come natively in some form of output. For Neptune Analytics, for instance, we're using the REST API, which will output in JSON, so you can just consult that information right there. You can download it, you can copy it, etc. We've got a more friendly tabular display that you can use. Now, a tabular display sort of depends on what type of data you're extracting. So for instance, when you're using Cypher, it's going to be tabular, simply because that's the way it forces the structure of the data. So a table display is usually best suited to those needs. And you can see you can sort of just navigate your data like this. But we've also got a little list display that allows you to see and filter the data as a list. You can see your data as tables. So for instance, we've got our tweets and users. You can just easily consult them as tabular data. Same goes for edges. If I click here, you can see my edges. In this case, it's mentions. We're offering additional features like the ability to leverage provider-specific APIs. So in the case of Neptune, for instance, it's the ability to quickly run a profile or an explanation of the query in just one click, where typically you might have to send an API call, or if you're using, of course, Graph Notebook, you'll then have access to all the Jupyter magics to achieve all that. And yeah, there's a lot of other things you can do. So the query editing experience is sort of core to G.V. This is sort of the main thing that we're offering along with the results visualization. The query editing experience itself, is built to just make your life easier writing a query. And a lot of this is informed by my own initial experience, working with graph databases. Like, what was my very first hour working with a graph database? And a lot of it was around, well, how does it work? How does it behave? How does the language itself work? And I'd typically be just eyes on the documentation on one screen, eyes on my little Gremlin console on the other screen, trying to figure out my queries. And so what we try to do is make that a little bit easier by putting all the information just in one place. So you'll see as you're kind of typing your queries, you'll have access to hints on the right-hand side, as well as suggestions. And all of this is done in an effort to just give you the right information to write your queries. So typically here, we're, for instance, writing a simple Gremlin query that just fetches us a bunch of edges. Is going to suggest me relevant edge labels as I'm typing. I can also see what the structure of the edges are. So, has location, I can see here is between a transaction and a location. There might be others. In this case, this is the only one. You can also actually use variables in your queries. So Gremlin and Cypher and a lot of other language have this concept of query parameters or query variables. The naming convention varies, but the language itself allows for the inclusion of parts that can be replaced with values in situ. So for instance, here, what I've done is I've put a little variable called edge_limit, fairly self-explanatory. This gets detected by G.V, and that allows us to basically enter the value here. Now, you might say, well, why don't you just enter it here, right? Now, the reason we allow support for those variables is that you can then save your queries. So I'll just call this one sample query. And you can prompt for the user to enter those values when they're trying to run it. So you'll see now my query has a variable. We've saved it, meaning other users that are using G.V will be able to access the same query. All they have to do is enter the information, and it will just run the query with those parameters supplied. And that just gives a very quick and easy way to build reporting around your graph data, for instance. So you might have some people that will focus on building those queries, putting the right parameters, and you'll have other people that maybe just want to run the query and see the information, no questions asked. And the only thing those people will have to do is just find the query in the list of reports, run it, specify the parameters, and they're kind of good to go.
That's a really neat feature, Arthur. I
think
that's really cool. And it's such a simple sort of thing, but yeah, I could see where folks would want to work with it that way, right? I also think, just going back to where you were before you got to the variables, I mean, I think that's one of the strengths of G.V is that the context it kind of gives you as it's as you're typing. Like, it's one thing to have autocomplete, but it's like a whole nother thing to have like an entire set of context popping up that's relevant to what it is that you're typing as you go. So
that's a frequent feedback we get. A lot of G.V users are first-time graph database users. So there are people that are going to kind of feel the pain of having to learn something new. And I've, like I said, experienced that myself when I first came across Apache TinkerPop. My first question was, what's Apache? What's TinkerPop? I was a little bit unaware at the time. And so having all these tools available basically does two things for graph database adopters or just general users. It's like, first of all, it gives them better tools to learn and interact with the database. But then also it's like, well, if you're working for any kind of technology team, you're going to, within your team, you're going to possibly need to show a bit of what you're doing, right? And G.V, is going to help you demonstrate the graph database work that you're doing, not just within your team, but also potentially to people that are not technical and that are not necessarily going to be capable of grasping the concepts of graph data unless they have a big graph right in their face that just tells them this is what your data looks like, and that kind of helps not only work with the technology but also kind of promote it internally. Hopefully, when you work on a graph project, you're confident and you're passionate about succeeding. And so this is the kind of tool that we've heard many times before from users that, yeah, we started our proof of concept straight off the bat with G.V, and we've been able to push it all the way to production in just a few months because we've not just been able to do our developer work, do our queries, figure stuff out, but also then actually tell people, look, this is what we're doing, this is what it looks like, this is how it works, this is what you can do with it, and that just helps ensure a better success rate. I'm not going to say guarantee success. There's never 100% success rates on any project, but it helps significantly.
Yeah. I think maybe one of the other things I'd say, like with all the context that G.V is providing, I don't know, you've still managed to kind of maintain the simplicity of the interface. It doesn't feel like, despite all the features, it doesn't feel terribly crowded in what it's doing. So that's kind of another nice thing I think I've noticed as you've evolved here.
Yeah, absolutely. And we're actually, in some cases, we're kind of we're working on improving G.V constantly. There's typically a monthly release. Monthly releases will generally be a combination of improvements, new features, and sometimes now new databases that we support. We're working on improving the overall graph visualization experience, for instance, trying to declutter it. If you look at the graph visualization right now, there's a lot of buttons, man. There's like 20 of them. We're going to streamline that a little bit to make it a little bit less cluttered. Overall, we're kind of looking at what other solutions are doing out there, right? Stuff like Neo4j Bloom, for instance, or their graph database browser and other paid or free products that exist to see what works best for users. Sometimes it's just our users telling us, look, this isn't looking very good, you should change that. And it's like, well, actually, yeah, I agree, let's change that. So we're very feedback driven, but we also kind of look at what others are doing to try and make the best product possible. I'm just going to wrap up on the demo. There's lots of other stuff. This is just a couple more things I want to show really quickly, just to kind of hammer in the points over what G.V does. One thing we've not really touched on is that G.V doesn't just allow you to query your data. It figures a bit more out about what is going on in your database, right? So, for instance, one of the struggles with unstructured data, I'm being a bit mean with unstructured data. Graph data is not unstructured, but you don't have a schema first approach where you're going to define your relationships, your nodes, the properties and all their constraints, and then build your graph out. You might just start chucking data on your database and then see what happens. And when you do that, it can get a little bit difficult to keep track of what the structure of the data is, especially if you're working in a team where one guy is going to do one thing and someone else is going to do something else. And so we just provide this super simple display of the structure of your data. So you'll see, for instance, right here is the data model for my Amazon Neptune cluster, and it really just tells us what's in it, right? So we've got transactions, locations, these are the relationships, these are the vertices, and these are their properties. And it just gives you a consistent view across the board of what the structure of your data is. Where possible, we leverage provider-specific APIs that give us that information. So for instance, Neptune Analytics has a really good give me the schema procedure that just tells you exactly what's in your database, and this is what we use to load it here. Where that's not available, we either load it by shooting a few queries to the database itself, relatively efficient queries. We're not trying to bloat, the database server, so we try and do that efficiently. Or if it's a really large database, then we simply build the understanding of the data schema as the user is querying data, which means run a few queries in your database and suddenly you'll have a populated data schema that tells you what's in it. And the last thing is, you can write queries in G.V. It very much is a developer tool, but you can also just search for it, with simple filters. So for instance, if I want to find person by first name, I actually don't know what the names of the people are in this, so I'm just going to do a very broad, someone with an A in their name. I'm just going to cheat a little bit. You can just run these filters and you can start getting that information. again, you can easily style your graph so that you can show the relevant information. So like for instance, for a person, we'll just show the first name. And that allows you to just get to the information kind of quicker without having to do the whole writing the queries part, which is something that, especially if you're less familiar with the language or less technical, you might not want to do. So we kind of try and offer a balance of the technical features and now more soft features intended for more business users. I'm going to move away from the demo, and I'm going to just basically talk about what's coming next. So let's go back to our slideshow. So the first thing is, as I mentioned, we are working to support additional graph database technologies. So currently we're very much in a labeled property graph sprint that's been going on for a few months, where we onboard labeled property graph technologies just across the board where we can. So we've got support for Kuzu coming soon. Kuzu is an embeddable Cipher graph database, and then we've got support for dgraph coming in as well. dgraph for distributed graph is what it actually stands for, is another type of graph database that has some RDF semantics to it, but it uses a different querying language called DQL, which itself is spawned off of GraphQL. It very much behaves and looks like a sort of graph API, but with additional provisions for graph-specific tasks. The ability to have edges and to do traversals and pathfinding, etc.
What is the state of dgraph at the moment? I see it's by hyper mode.
Yeah, so dgraph has been, I don't want to use the wrong terminology here, I believe acquired is the right word, by another company called Hypermode.
Okay.
Hypermode is building just AI tooling. Generally speaking, their work is around commoditizing the deployment of AI models and workflows with the added sort of benefit of using an internal, well, not an internal, but using a complementary knowledge graph structure to help inform the decisions of the AI models that are going to be performing tasks. I will say you're better off checking the Hypermode website directly to get a good pitch on what they actually do. But I think the important part is that they recognize the importance of knowledge graph within this sort of blooming Gen AI, not AI, Gen AI space. And they've basically taken the combination of AI models, large language models rather, and knowledge graphs to try and create a solution that both streamlines the deployment of AI workflows, as well as attempt to ground them with knowledge graph representations that try and keep them as accurate as possible. They're compatible with dgraph, which is sort of their innate graph database, but they're also compatible with other graph databases. I think Neo4j, for instance, is something they've recently showcased. So there's a lot of stuff going on there.
Okay.
As far as GW goes, there's a few things that are on the horizon that we're aware of or working on or planning to work on. So the first one is Apache TinkerPop 4. Now, Apache TinkerPop 4, last time I checked, was in beta, so it's very much coming. And it's something that we're closely monitoring simply because, as part of our mantra, so to speak, we want to provide support across the board as much as possible. And that means that we are going to need to be able to work concurrently with Apache TinkerPop 3 databases and Apache TinkerPop 4 databases. Apologies, I'm using databases a bit loosely here, but hopefully you understand what I mean. There's probably going to be a bit of a scale in terms of adoption from various TinkerPop providers. So I'm thinking, for instance, about Janus Graph, Amazon Neptune perhaps as well, Aerospike Graph, etc. And that's not going to happen overnight. So there's probably going to be several months overlap or years perhaps even, where vendors will both be on TinkerPop 3 and TinkerPop 4. And for us, it's not going to be acceptable to just cut Apache TinkerPop 3 loose and no longer support it, or completely ignore Apache TinkerPop 4 as well, because users that want to adopt Apache TinkerPop 4 that are using GW will expect to be able to use it as well. So as of just now, we've not got any concrete plans. We've got sort of theories as to how we could support both of them concurrently. And we're essentially trying to ensure that we come up with a good plan as to how we manage this transition. We've got a bit of time, fortunately, to make it happen, but we'll be looking to stay on top of TinkerPop 4 as well to help the adoption and to provide support for it as soon as reasonably possible without compromising on the availability and compatibility of TinkerPop 3 in general. So there we go, RDF. I promise we're going to get there. So yeah, RDF support is something that's quite important, both I think in terms of G.V as a tool, but also just generally speaking for the graph database space. I mean, when we talk about graph databases, and I don't want to, I'm not able to quote any market reports, but I feel like we're at least a 50-50 split, possibly even more favorable towards RDF, where a lot of the technologies that are out there, a lot of the people that are using these technologies are not using labeled property graph, they're using RDF. Now, with RDF, some providers will have their own tools, others might not have their own tools, or they'll have, for instance, aging tools. And so for us, having looked at RDF and discussed with a few people in the space, the conversation generally revolved around, can we do something? Can we do something useful in the space that provides, can we provide a solution similar to G.V in its current state to the RDF users, and will they find it useful? And from conversation, what we're getting at is, yes, there's a potential need for this. We have had users, first of all, just outright ask us if we could support RDF, of course, but then also looking at the wider ecosystem, there's a bit of a transition, so to speak, with RDF. And for us, it's a good time to get involved. Now, realistically, because as I've kind of mentioned before, it's just two of us working on G.V, this is going to take some time. But the good news is that we have not sponsored, we have Neptune to the rescue with Sparkle support right out of the bat, which makes it a lot easier for us to integrate with, because we already integrate with all the other Neptune APIs, as in Cypher and Gremlin. Introducing support for a new language through Amazon Neptune is the easiest path in terms of development. It means we only have to focus on the language and the data structure. With RDF, of course, the language being Sparkle, and the data structure in this case being RDF. So what we're looking at is a 3-stage implementation. The first stage is to simply support Sparkle on Amazon Neptune with a very basic way of mapping triples to nodes and edge structures, just relying on the innate classes that are defined through RDF. That's the step one. Step two is going to be to look at supporting structuring the data, leveraging ontologies. So as of just now, the way we're looking at it and the way I've sort of discussed it and been advised to do it, subject to change, of course, is to start with Shackle as a way to structure triples data in order to provide visualization around it. That would also require effectively supporting other databases than Amazon Neptune itself. So we'll be evaluating which graph databases, RDF triple source rather, let me rephrase, would benefit most from the availability of G.V as a tool. And those are probably going to be the one that we'll start with. Generally speaking, we don't want to be in a situation where we're making a tool that's not as good as what the graph database provider already provides, because then we're not doing anything useful, right? And then level 3, with a question mark as of just now, because my understanding of RDF, hopefully not coming across too limited, but is limited nonetheless, is to look at OWL support and to just expand support for other triple source. So this is going to happen, over a set period of time. I would like to have level 1 done in 2025. It's only February, so we still got a good bit of time. And then potentially level 2 as well. Level 3 is, as far as my understanding goes, a good bit more involved. If we look at ontologies, there's a lot of conversations around ontologies around some problems that might even seem simple, but how do you visualize an ontology? It's not that straightforward. There's a lot more information to be shown, and so therefore we're having to spend a lot more time and potentially consult with people in this space to make something that is useful once again. So that's generally what we've got in store for RDF support. We'll basically be kind of posting updates as we go working on this. It's not the only thing that we're going to be working on, of course. So we got a few other goals for 2025. So one of our primary goals now.
Just a quick interruption.
Yeah, of course.
I don't know if you can see the chat or not, but there is a comment from Josh here. He says, one thing which would be really useful even before you have the Sparkle support at the query level is just to be able to visualize an RDFS or OWL ontology, which would probably be a little more straightforward to map an ontology into whatever internal representation you're using there.
Yeah, that's right. And this is, so I've been kind of sort of looking at the way people do it. There's someone that's been posting stuff on LinkedIn recently. I forgot the name, unfortunately, so it's going to be uncredited. Has been documenting a journey of, how do we turn an ontology into a useful representation? And so this is the kind of material that I've been feeding off of to try and get a better understanding. I think conceptually, being able to do this in GDLV will help users, but actually will help me as well at figuring out what I'm doing in the first place. So there's certainly a bit of a learning journey, and I'll definitely be taking all the advice I can get. For just now, I've been consulting with someone called Kurt Kegel, who's kind of helped me put together a sort of general analysis of what the RDF space looks like, what the different types of technology are, whether there's an opportunity to do something useful, and what the considerations should be when moving from an LPG representation to an RDF. And I'm potentially, or in fact, most definitely going to be using services of experts in the RDF space in order to inform all of this, to make sure that I'm not just shooting in the dark, making some random RDF tool that has no grounding in what RDF users actually need or want to do or use. I'll be looking at experts providing me insights as to what exactly is needed, what should it look like, what should it do, etc., etc. So right now, because it's early stage, I'm probably coming across a bit uneducated, but one of my goals is going to educate myself over time in order to make a sort of like informed implementation of that support down the line. So yeah, just in terms of like our goals in general, we're going to continue with user experience improvements. The software, as I've kind of mentioned before, was being developed by myself alone part-time. That has obvious implications on the quality. And that's not to say GDLV is a bad quality software, but it just means that certain things like user experience are kind of being put a little bit on the back burner sometimes. Sometimes we focus on getting something done that's good enough, that's not fully polished. And so now we're spending a lot more time polishing the existing features, making them look better, making them like easier to use, so that when users are starting to use G.V, they have just an overall more pleasant experience, right? And that both serves us in like keeping people around and hopefully getting them to buy the software, but also it just gives users a better tool to work with. We want to limit stuff like frustration using the software. We want to make sure it's as pleasant as possible. And so we've been doing, and we're continuing to do a lot of that. The other thing is, so I've kind of mentioned we've got this web version of G.V on the AWS Marketplace. I am not planning to have it only in AWS Marketplace forever. The ideal sort of roadmap for the web version is to fully integrate it with what I call enterprise-ready solutions. The first thing that people are going to be looking at when they want to deploy the web version of G.V at a wider scale, across say 50, 100 users or whatever is proper authentication means, for instance. Right now on the AWS Marketplace version, it's all handled through Nginx, the reverse proxy. It's not the best. It's just allowing to have a basic form of authentication, but we're going to perform an integration with a solution called Keycloak. If you're familiar at all with the identity and access management space, Keycloak is essentially an authentication and authorization service solution that's open source. And that makes it really easy to provide, things like permission management, single sign-on, user ingestion through directories, etc., attaching it to any sort of application and just bundling it as an enterprise-ready product where you have, in this case, G.V being like the product, and Keycloak being the authentication and authorization front that will allow users to just access G.V securely and with authentication and all that. So that will definitely happen before the end of Q2, and that will first get released on AWS Marketplace, but then will then be used as a starting point to release G.V, the web version, outside of AWS Marketplace, where it'll become this is how you deploy it. This is your Keycloak server. This is G.V. This is your database. Here's your Docker Compose. This is how you configure it. And then people can just deploy internally, for instance. So this is kind of also there's been mentioned there, which is to release this web version outside of client marketplaces and to support additional graph databases languages. So again, continued expansion here. One of the things we're interested in is SQL 2023, which has added the provisions for the creation of property graphs on top of relational data. Something that, for instance, Oracle Graph Database does. It started off as PGQL, I believe was the name, and they've evolved PGQL, which was a sort of Oracle-specific technology, into an extension of the SQL standard to allow the use of graph on top of relational data. It's kind of a theme that's been popping up a little bit in the last year and a half or so, where we're seeing more technologies that are providing graph, but not on top of a graph store, but rather a relational store. And so we're kind of seeing this as a direction that's worthwhile heading in, because ultimately there's going to be different types of graph database users. There'll be ones that are using specialized or native solutions, and then there'll be ones that are just coming from the relational world that are looking for something quicker and easier, based on what they already have. The other thing is a lot of the stuff that we do in G.V right now is very dev focused, right? So we want to start introducing more analytics, analyst user-friendly features. The ability, for instance, to create dashboards, visualization dashboards based on your data. So previously I'd shown these queries where you could add parameters. The idea with the dashboarding features, which unfortunately I can't show today, is that you would be able to create a visual dashboard with different types of data visualization, like pie charts, Sankey charts, tables, graph views, etc., based on parameterized queries. Wherein the idea would be that a backend engineer, for instance, might create the dashboard, configure it with all the queries and the visualizations, so that a business user, for instance, would then in turn be able to just provide the parameters to a dashboard and get a sort of comprehensive view of a specific problem that the dashboard is aiming to provide information on. We're also going to add some graph analytics features in there. So currently it's going to be focused on client-side graph analytics. For a good parallel, if you've ever used something like Neo4j Bloom, they'll allow you to run a bunch of easy algorithms, community detection, centrality, etc., directly on the graph view, and then apply graph visualization rules that highlight the results of the actual analytics being run. Since G.V allows showing a lot of graph elements, it technically gives us the ability to run more useful, rather run these algorithms at a slightly higher scale. We're not talking millions, of course, because rendering millions of elements is just generally not a great idea. But you could be running, for instance, analytics algorithm over graphs of tens of thousands or even 100,000 elements quite easily, and still be able to receive a visual that gives you an overall idea of the output of the algorithm. So typically for community detection, for instance, it would be organizing the actual detected communities into visual clusters. So you can see there's one community there, it's the biggest one, there's another one there, etc., etc. We're hoping at least to continue supporting and sponsoring the Sigma.js visualization framework, which is what we use to do the graph rendering in G.V. If you're not aware of Sigma.js, if you've not used it and you're looking at doing graph visualization, I would highly recommend checking it out. It's a really good framework. It's very easy to develop with, and it's high performance. We've been sponsoring their work for a bit over a year now, and we're planning to continue doing so that they can adopt an ever more ambitious roadmap. We would like to start doing something with GQL. So GQL has been out now, the standard for, I want to say it's possibly been almost a year that it's been ratified. I need to jog my memory a little bit. We're kind of monitoring what graph database vendors are doing with it. Some technologies are starting to come out with, for instance, a GQL compliance report or specification that says, well, look, this is the GQL standard. of the GQL standard, these are the functionalities we support. And for us, the idea is that, well, as vendors start adopting GQL, they will possibly, users or vendors both, be interested in tooling that supports GQL as a whole. So, the same way you can run and write a Gremlin query on G.V, we'd like for this to be possible with GQL. The only caveat you'll see I've added to this is that subject to the wider vendor adoption. Right now, there aren't too many providers that are GQL compatible, so it's sort of a reduced benefits effort. We're not going to be able to help many users, but I suspect as time goes that we're going to see more of those adopting it, and therefore it will be more valuable to the users to have that support. It might also be a way to actually help users transition from whatever perhaps native language their graph database used to GQL if that specific graph database decides to adopt it. And then, yeah, finally, like I said, we're a team of 2, so we've already quadrupled our capacity since June. But revenue allowing, we will look to expand the team further just to allow delivering more ambitious features over time. So we're just about at the end of the presentation. I just want to throw in a few notes here. For those who have been using G.V for a while, you'll know that we're very much about feedback. We started out as a free open beta software, so we can collect as much feedback from users as possible. Even though we are now charging users, that does not mean we are not interested in feedback. In fact, quite the opposite. So, for us, it's always useful to hear about, well, what can we do better? What should we do in our software that would help you, the user, better work with your graph database? If you're using G.V and you would like to support us and continue using G.V, you can purchase a license. That, of course, goes directly to the team and to the product. Whenever someone buys a license, you're kind of guaranteed this is going to pay the salaries of the very small team and allow us to just continue working on it and possibly get more people. So you can contact us directly by email, or you can just ping us on Discord because we'll be there as well. If you got good things that you want to say about G.V, if you've used it, you like it, just let us know. That's always nice to hear. That kind of helps motivate us. We have a LinkedIn page, because G.V is now running as a company. We have the obligatory marketing work to do, and LinkedIn is a very good place for us to kind of post, what's happening with G.V to a sort of wider crowd. So, if you want to find out, just follow us on LinkedIn, and you'll be able to see, for instance, developer previews, like new features are coming up, or just new blog posts, etc., etc. G.V, of course, is something that you can try whenever you want. So there's a few things. First of all, there's always a 1-month free trial on the desktop version. So if you download G.V, install it, you'll be offered to sign up for a trial when you connect to your database. But there's actually also a completely free version that allows you to do a few things. So for instance, if you're using a database that is less than 500 vertices and 500 edges, you can just use G.V for free outright. You could do whatever you want with your database as long as you're within that threshold. You'll not be asked to sign up for a trial. You'll not be asked to pay for anything. The goal is to kind of give users a tool that they can just use early on to just play with their graph data without having to worry about a paywall. So you've both got the trial and the free version. You can also do in-memory graphs in the free version with no restriction. That just allows you to, for instance, if you want to learn Gremlin, you can spin up the ever so famous air routes graph that has been curated by Kelvin Lawrence, and just do a little follow along of Kelvin's book Practical Gremlin to just learn the language whilst using G.V just completely free of charge. You can also try the AWS Marketplace version for free. There's a 2-week trial on that. So that just, again, allows you to kind of give it a go. And yeah, there's a few ways basically you can use G.V without necessarily having to fork it, at least right away. So, if you've not tried it before and you're kind of worried, well, what is it going to cost me? It doesn't have to cost you anything, at least not right away. So you do give it a try, give it a chance and see how it might help you with your graph data project. Couple other things. For the first time, I'm going to be doing a conference So we will be, as in the G.V team, myself and Joe, we will be in New York for a whole week from the 5th to the 9th to go to the Knowledge Graph conference. So we're actually going there as a sponsor, which means that we'll have like a little table. We'll get a couple 5 minutes talk as well, but we'll also just be roaming around in general because the conference is structured in such a way that there's presentations as well as sort of floor space for vendors. So we'll kind of be doing both. And we've also got a blog that you can just check out where we try and post useful articles that either showcase what's coming up or what's new in G.V, or we'll discuss graph database specific aspects. For instance, here's the difference between G.V and Azure Cosmos DB Data Explorer, or how do you get started with PuppyGraph, etc., etc. And that's everything for me. So thanks a lot for sticking with me to the end. If you've got any questions or comments, fire away. I'm happy to answer.
Well, thanks, Arthur. As usual, I'm always kind of amazed at how much you can get done in the intervals between when we kind of do these sessions. So definitely a lot of things on there. I think there were a number of comments in Twitch. I mean, I called out a few of them as we went along. And I think just scanning back through, there was definitely some agreement that the query variables feature was really neat. So we did touch on that. There was some agreement there. And let me see what else there was. I think, let me see, I think you already had some discussion in Discord about Sigma.js with someone, with Chris, I think it is. I think it's Chris McGinnis.
Yeah, that's right.
And so I think that there was some mention of that on there. Josh called out that there's some more GQL implementations definitely on the way. And so I guess we'll be looking for those. Yeah, I think that's kind of it. I don't see any questions in Discord. So unless anyone has anything else, we'll kind of call it at that. But definitely appreciate you coming on here and doing this. I think we learned a lot about what's the latest in G.V and what's happening in that space. It's really exciting to see it kind of grow from just its little beginnings with Gremlin into having, I mean, you scrolled through, I don't know, almost like a dozen different providers that you're supporting. Do you know the number just offhand?
A good question. It's possibly 12 to 15. I will say most of those providers are Apache TinkerPop. But there's a growing list of Cypher ones, as well as GQL, so to speak, with Spanner Graph. I expect there'll probably be at least, I want to say 5 more providers added this year, possibly more. The thing is with Cypher and TinkerPop as well, right? Is once you support the base sort of language and the base structure, it becomes a lot easier to add support for other technologies. And if, for instance, some other provider decide to adopt the Apache TinkerPop framework, it'll probably be quite straightforward for me to then add support to it. And that same idea goes to an extent with Cypher. There's some specifics. Sometimes I'll need to use specific drivers for a given technology, which will require a bit of integration. But overall, the process of integrating graph database technologies with support languages that we already support is relatively quick. I mean, for Kuzu, for instance, which is an embedded Cypher database, because it's embedded, you can't, for instance, connect to it with the Bolt protocol. It doesn't make sense. It's embedded. There's no network there. So we had to use their own driver, but the actual process of then implementing that support was really quite quick. There were a few sort of differences. For instance, sometimes there's differences in the Cypher language itself. So Neptune, for instance, will use OpenCypher with some slight subtleties, for instance, with RDF prefix support. Kuzu will use a sort of enhanced version of OpenCypher with Kuzu specific statements. Neo4j, of course, will use their Cypher. Memgraph has Memgraph Cypher. So those are some slight subtleties to implement for there, but overall, it's becoming more and more straightforward by the day. And so whenever users come to say, well, actually, I'd like to be able to use G.V with this graph database, then we can typically do something that it will usually take a bit more time when it's a new language. So, for instance, with GQL, Google Spanner Graph or dgraph, there's a little bit more work involved, simply because I have to not just allow the users to run the queries and view the results, which is typically the easiest side of things, but I also have to allow them to write the queries and get some syntax validation and all that, and that takes a bit more time. But overall, we're talking timescales of weeks maximum. So that means we can cram in quite a few every year as well. And like I said, working on it full time, it just gives me so much more time to get stuff done. So that sort of expansion is going to continue. And hopefully a bit later in the year, I'll be able to actually report proper progress on the things that I've not promised, but attempted to speculate will be done this year. So we'll see in 6 months' time, but I expect we'll be well on time, and that will hopefully allow us to do some other things as well. There's just so many things that can be done. Sure. We're just trying to prioritize, what's the most useful to our users, and typically the easiest way for us to know that is for the users themselves to tell us, actually, this would be really useful, and that's generally what informs our decisions in terms of what goes in the software.
Okay. Well, I think this is, like I said, this is kind of neat. I think this is also maybe perhaps a prelude to, a future wider discussion about UIs and graphs and graph visualization. We did have some talk in Discord that I saw that showed some interest there. And I don't know, Chris is somebody who was interested. I'd like to see who else we might be able to get to kind of talk about this stuff and see where that goes.
Yeah, absolutely. I think it'd be really interesting. It's one thing to interact with your graph database and be able to write your queries about it, but sometimes you might want to build your own specific application on top of your graph data, and that will occasionally require the use of graph visualization. So there's a few people here and there, I think, on the Discord that have implemented these solutions, myself included, that can hopefully provide some useful insights as to things to consider and trade-offs, and how or what does a good graph visualization user experience look like. Not saying we've got the best graph user experience, but we've put a good bit of work on it now.
All right, great. Okay, well, I think with that, I don't see any more questions, so I think we will sign off from here. Thank you again, Arthur. Thanks for everybody who participated today and watched everything here, and look out for our next one.
Thanks, everyone. Take care. Have a nice rest of the day.
Bye.
Bye.